can you estimate decimal quotients? That's our question for the day. So we are going to figure out how to estimate decimal quotients. This will help us to place our decimal point in our answer. And when we talk about quotients, what does that mean? What are we going to be doing? What operation?
Division.
Division. Okay. Here's our story for the day. It says Carmen likes to ski. The ski resort where she goes to ski got 3 2/10 feet of snow during a 5-day period. The average daily snowfall for a given number of days is the quotient of the total amount of snow and the number of days estimate. So the total amount of the quotient, meaning the answer to our division problem, the total amount of snow and the number of days estimate the average daily snowfall. So we're going to take our total amount of snow and we're going to divide it by our number of days. So 3 2/10 divided by 5. Carly and her friend Marco each find an estimate. Since the divisor is greater than the dividend, 5 is greater than 3.2. They both first rename 3 2/10 as tenths. How many tenths is that? What would we have to do to make that be tenths? If we wanted to make that a whole number, we would have 32 tenths. Okay, we would multiply it by 10. Carly's estimate, 30 tenths, is close to 32 tenths and divides easily by 5. Use the basic fact to find 30 tenths divided by 5. 30 tenths divided by 5 is 6 tenths, or 0 and 6 tenths. So the average daily snowfall is about 6 tenths. Whose estimate, we better look at Marco's, I guess. Marco's estimate, 35 tenths, is close to 32 tenths and divides easily by 5. Use the basic fact. So 35 tenths divided by 5 tenths is 7 tenths, or it can be written as 0.7. So the average daily snowfall in Marco's estimate is 7 tenths. Whose estimate do you think is closer to the exact quotient? Explain. Let's look at their estimate. Who is closer to 32? Carly with 30 or Marco with 35?
Carly.
Carly with 30. Okay? So if we were going to explain our reasoning, we might say we would answer Carly's estimate first of all. And our possible explanation would be that 30 is closer to 32 than 35 is. And they use the same. Okay, so whose quotient is closer? Like we discussed, Carly's estimate is closer. 30 is closer to 32 than 35 is, and they use the same divisor. So if you were writing it in the math words, that's what it might sound like. Okay, so number 2 at the bottom of page 209. They want you to explain how you would rename the dividend in 29 7/10 divided by 40 to choose compatible numbers and estimate the quotient. Again, I do not have a division sign on my computer keypad, so the slash is the same as divide. Your answer would be, I would rename 29 7/10 as 297 tenths. Then I would find compatible numbers that divide easily by 40. So multiples of 4 or 40. So 280 divided by 40 is 7. 7 times 4 is 28. Or 320 divided by 40, which gives you 8. And 4 times 8 is 32. Okay, now we moved on to page 210. Here's a little help box for you. When you estimate quotients with compatible numbers, the numbers you use for the dividend can be greater than the dividend or less. Just like our 280 was less than 297, and our 320 was greater than our 297. Here's our question. A group of 31 students is going to visit the museum. The total cost of the tickets is $144.15. How much money will each student need to pay for a ticket? So we're going to estimate $144.15 divided by 31. So looking at, use 30 for a divisor. So we're going to round our divisor to the nearest 10, and that would be 30. So now we have to find something that's close to 30, or that can be easily divisible by 5, that's close to 144. And the first thing that comes to my mind is 150. And 150 divided by 30 is 5, right? 5 times 3 is 15. So each student will pay about $5 for a ticket. Use a whole number less than the dividend. Use 30 for the divisor, then find a number closer to it, but less than. So if we're doing our multiples of 3 or our multiples of 30, we would have 3, 6, 9, 12, and then 15. We already used 15, so we're going to go back to 12. And so 30 times 4 is 120 divided by 30, and that will give us 4. So it could be about $4 per ticket. Now the question is, which estimate do you think will be a better estimate of the cost of the ticket? Which one would be better, the $5 or the $4? Hey, we're talking about money. Would you want to estimate low if you were using money?
No.
Because you wouldn't want to walk up to the ticket booth with $4 when it was really going to cost you $5. So it's probably better to estimate on the high side when you are estimating with money. So in this particular case, your best estimate is probably the $5. So this is number 3 toward the bottom of page 210. The question was, which estimate do you think will be a better estimate of the cost of the ticket? And we talked about how you're estimating money, you want to estimate on the high side of what you would need so that you don't come up short. So the $5 estimate, because it's better to know the greater estimate in order to have enough money for the ticket. Okay, the Sharon show at the bottom of page 210, it says use compatible numbers to estimate the quotient. Okay, so when we have 28 and 8/10 divided by 9. Let's think of our multiples of 9. What's a multiple of 9 that's close to 28?
3.
3 times 9, which is?
27.
So we would estimate this to be 27 divided by, and we could leave our divisor at 9, which would be 3. Second one is 393.5 divided by 41. Let's look at our divisor. What are we going to estimate our divisor to?
40.
40. Okay, now think of your multiples of 4 that are close to 39.
36.
36. What would be the next? 40. So which is closer, 36 or 40?
40.
So what can we round this to?
No.
400. And how many 40s in 400? 10. So that's what you need to be thinking of. How many 4s can go into 39, or what's the next closest number they can go into? Okay? Turn on over to page 211. This is number 6 on that page. We're going to divide by 4. So 15 and 5/10 divided by 4. We're not going to change this divisor. So we're going to leave our divisor at 4. What are the multiples of 4? 4, 8, 12, and 16. Okay, so if I'm at 12 is lower than 15, just lower, and 16 is just higher. Which one, though, is closer to 15 and 5/10? 16. So 16 divided by 4 is 4. one is number 10 on our page. Now, 52 is probably not something that we can easily divide something by, right? So what are we going to do with 52?
Round it to 50.
Round it to 50. Now, if we think of our multiples of 5, which ones are closer to 32? 30. We could go 30, which is 6 times 5, or 35, which is 7. But 30 is closer. So let's round this to
300. Right?
30. No, we wouldn't want to go clear to 300. That'd be way bigger. Now, 30 divided by 50.
1 and 2.
Can 50 even go into 30?
No.
So we're not going to have any whole numbers, are we? Now, we could add another 0 to our 30, and then what would we be at?
300.
300. So how many 50s in 300? 6. Or we could have made this 300. We could have made 32 and 4/10 into 324 tenths or 300 tenths. And divided that by 60, or 50, sorry. And then it would have went in 6 times. So we have to have that decimal place for our tenths. And the next one is number 14. So let's think of this 42 as what? 40. Okay, and 759 and 92 hundredths, or $759.92. So how many
8.
40s?
2.
Okay, 2 40s in.
8.
What are we going to round 759 to?
8.
800?
Equals 2.
Not 2, but
20.
20. So there are about, or 759 and 92 hundredths divided by 42 is about $20.